In this video, let's talk about the summary of the WLAN configuration or the summary of our chapter 13. Subtopics of this main topic is to remote site WLAN configuration, configure a basic WLAN on the WLC, configure a WPA2 enterprise WLAN on the WLC, then troubleshoot WLAN issues. Then we are going to summarize all of this. Remote workers, small branches office and home networks often use a small office and home router. These routers are sometimes called an integrated router because they typically include a switch for wired clients, a port for an internet connection, sometimes labeled WAN, and wireless components for wireless client access, shown. The most wireless routers are ready for service out of the box. They are pre-configured to be connected to the network and provide services. For example, the wireless router uses DHCP to automatically provide addressing information to connected devices. However, wireless router default IP address, usernames, and passwords can easily be found on the internet. Just enter the search phrase default wireless router IP address or the default wireless router passwords to see a listing of many websites that provide this information. For example, is the username and password for the wireless router in the figure is admin. Therefore, your first priority should be to change these defaults for security reasons. In small office or home network, one wireless router may be sufficient to provide wireless access. To all the clients. However, if you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you can add wireless access points. Then, many routers have an option for configuring quality of service or the what we call QoS. By configuring QoS, you can guarantee that certain traffic types such as voice and videos are prioritized over the traffic that is not as time sensitive. Such as email and web browsing. On some wireless routers, traffic can also be prioritized on specific ports. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of a LAN. However, there are situations when specific ports must be open so that certain programs and applications can communicate with devices on the different networks. Port forwarding is a rule-based method of directing traffic between devices on separate networks. Topology and addressing scheme used for the bridges and in the table, the access point is controller-based AP as opposed to an autonomous AP. Recall that controller-based APs require no initial configuration and are often called lightweight APs, or what we call LAPs. LAPs use the Lightweight Access Point Protocol or the LWAPP to communicate with the WLAN controller or the WLC. Controller-based APs are useful in situations where many APs are required in the network. As more APs are added, each AP is automatically configured and managed by the WLC. Configuring a wireless LAN controller, which is WLC, is not that much different from configuring a wireless router. The big difference is that WLC controls APs and provides more services and the management capabilities. Most WLC will come with some basic settings and menus that user can quickly access to implement a variety of common configurations. However, a network As a network administrator, you will typically access the advanced settings. Then, wireless LAN controllers have ports and interfaces. Ports are the sockets for the physical connections to the wired network. They resemble switch ports. Interfaces are virtual. They are created in software and are very similar to VLAN interfaces. In fact, each interface that will carry traffic from the VLAN is configured on the WLC as a different VLAN. The 3504 WLC can support 150 access points and 4096 VLANs. However, it only has 5 physical ports. Then, each WLAN configured on the WLC needs its own virtual interface. The WLC has 5 physical ports for data traffic. Each physical port can be configured to support multiple WLANs, each on its own virtual interface. Physical ports can also be aggregated to create high bandwidth links. In the previous topic, you learned about WLAN configuration. Here we will discuss the troubleshooting WLAN issues. Network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. This process is called troubleshooting. To assess the problem, determine how many devices of the network are experiencing the problem. If there is a problem with one device on the network, start the troubleshooting process at that device. Of course, if there is a problem with all devices on the network, start the troubleshooting process at the device where all other devices are connected. And the best example there is the router or the switch. Then you should develop a logical and consistent method for diagnosing network problems by eliminating one problem at a time. When the user PC is eliminated as the source of the problem, the physical status of the devices is confirmed. Begin investigating the performance of the AP, then check the power status of the access point. Then let's go to the troubleshooting when the network is slow. To optimize and increase the bandwidth of 802.11 dual band routers or end access points. To improve the range of wireless network, ensure the wireless router or AP location is free of obstruction, such as furniture, fixtures, and tall appliances. This blocks the signal, which shortens the range of the WLAN. If this still does not solve the problem, then a Wi-Fi range extender or deploying the powerline wireless technology may be used. Most wireless routers and APs offer upgradable firmware. Firmware releases may contain fixes for common problems reported by customers as well as security vulnerabilities. You should periodically check the router or access point for updated firmware. In the figure, or in the network administrator is verifying that the firmware is up to date on the Cisco Meraki. Summary: the remote workers, small branches, office and home networks often use a wireless router, which typically include a switch for wired clients, a port for an internet connection, and wireless components for wireless client access. Most wireless routers are pre-configured to be connected to the network and provide services. Then, the wireless router uses the receipt to automatically provide addressing information to connected devices. Your first priority should be change the username and password of your wireless router. Use your router's interface to complete the basic network and wireless setup. If you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you can add wireless access points. The router will use a process called Network Address Translation or NAT to convert private IPv4 addresses to Internet Routable IPv4 addresses. By configuring QoS, you can guarantee that certain traffic types such as voice and video are prioritized over the traffic that is not as time sensitive such as email and web browsing. Lightweight APs or the LAPs use the Lightweight Access Point Protocol or the LWAPP to communicate with the WLAN controller. Configuring a wireless LAN controller or WSC is similar to configuring a wireless router except that a WSC controls APs and provide more services and management capabilities. Use the WSC interface to view an overall picture of the AP system information and performance. To access advanced settings and to configure a WLAN, SNMP is used to monitor the network. The WLC is set to forward all SNMP logged messages called traps to the SNMP server. For WLAN user authentication, a radio server is used for authentication, accounting, and auditing, or AAA services. Then there is 6 steps to the troubleshooting process. When troubleshooting a WLAN, process of elimination is recommended. Of course, common problems are no connectivity and poorly performing wireless connection with the PC's operational. To optimize and increase the bandwidth to 2.11 dual band routers in APs either upgrade your wireless client or split the traffic. Most wireless routers and APs offer upgradable firmware. Firmware releases may contain fixes for common problems reported by customers as well as security vulnerabilities. You should periodically check the router or AP for updated firmware. And that will conclude the summary of our chapter 13.